So in this video, I'm trying to show you some examples of graphing inequalities of one or two variables on a coordinate plane. So before we get to the coordinate plane, let me start with some simple examples here. I'm above number 1. It says check whether this specific order pair, 0, 0, is a solution to these three problems. So I'm supposed to, let's go to number 1. It looks like x value should be substituted with 0. So I should have 0 is greater than -4, which of course is a true statement. So I'm going to say yes, which implies that 0, 0 is a solution to the problem. Number 2, same order pair, but the inequality changes. I need to replace according to this y with 0. So I have 0 is greater than 3. That is not true. It's a false statement. So the answer is no, which means 0, 0 is not a solution. Let me go to number 3 and fix my lines here. All right, number 3, same order pair, so 0 plus 0, which is equal to 0. And this is telling me that 0 is less than or equal to -3, which is false, because 0 cannot be less than a negative number, false. So no, which means 0, 0 is not a solution to my inequality. So as soon as they're asking you to check if a specific order pair works or not, in your head you're thinking substitution. That's what you should be doing. So let me move on to number 4. And it's kind of the same scenario here, but I have a problem with two order pairs given to me. So let me start with the first one, x and y. So if I substitute them correctly, just need to make sure this is okay. If I substitute them correctly, here's what I have. I have -2 minus 3. Let me clean that up. Well, -2 minus 3 is, you're adding two negatives, so more negatives, -5. And I want this to be greater than 5. And of course it's false, because a negative number cannot be greater than a positive number. So for the first one, it's a no. Let me go to the second one. So my x is 4 and my y is 1, so I should have 1 minus 4, which is equal to -3. So I want -3 to be greater than 5, which again is false, because I can't have a negative number being greater than a positive number. So no. So these order pairs, none of them is working for this problem. None of them is a solution. Let's go to number 5 now. Number 5. First one says if I substitute correctly, -1 plus -5, you're adding two negatives, so you're getting more negatives. Is -6 less than -3? Yes, it is. On the number line, it would be to the left of -3, so it's smaller. So it works. So this is a yes, which means a solution. Let me go to the other one, to 0, 0. So I should have 0 plus 0, which is equal to 0. Is 0 less than a negative number? No, it is not. So that's a no. So that's a yes, and that's a no. So it depends every time. We can't predict from the beginning unless we substitute and do our operations. So for all of these, you have to substitute before you say yes or no. And of course, we're assuming that you know how to perform the operations correctly. Let's go to the next screen. All right, so here is where we're starting sketching. So let me choose a marker here, and I need my line to be thin. All right, so if you remember from what we have done in the past, if I treat this as an equation, it would be y equals a number, and y equals a number should be a horizontal line. First of all. Second, because the sign, the inequality symbol is less than strictly, that means my line has to be dotted. If an equal is not included, the line has to be dotted. So let me go to y equals 1, which is right here, assuming that the graph goes by ones, and I need to bring a dotted horizontal line. Here we go. With inequalities, after you draw your line, you have two half planes. For example, here I have a half plane that is above the line and a half plane that is below the line. one of those half planes has to be shaded, which means one of those half planes will be covering or including all the solution to this inequality, all the solutions. Here it's kind of simple because it says less than, so less than would be under the line. So anything under the line should be highlighted or shaded, which means that is where the solutions are, which is indeed true. So if you go in here in the shaded region and choose any order pair that you want, any, let me just go and choose, for example, this. This order pair is 1, 2, 3, 1, 2. So it would be 3, -2. So because it's in the shaded region, in the shaded area, it should be a solution to this. If you substitute y with -2, -2 is less than 1 indeed. You're getting a yes. So everything in here should be giving you a yes, which means everything should be working. The opposite is still true. If I go here and I choose a point, let me choose a point right here. So this is -1, -2, and 1, 2, 3 up. So that is -2, 3. So according to this, because it's not shaded, it should not be working. If you put this in the inequality, you're getting 3 is less than 1, which is false. Not working, it's not shaded. Let's go to number 7. If I treat number 7 equality as an equation, I would have x equals -2. We have learned in the past that x equals a number should be a vertical line at -2. So it's right here. Because I do have the equal sign included, I want my line to be solid. And again, this is kind of straightforward. My two half planes are one to the right and one to the left. Because it says less than, I need to go to the left. That's where the less than area is. So everything in here should be shaded, everything. Now, be very careful with dotted or solid line. The line before for number 6 was dotted, which means points on the line should not be solutions. The line here is solid, which means points on the line are solutions. For example, if I go and choose this point right here, this point right here is -2, 0. It should be working because it's in the shaded area. So if you put -2, 0 in here, you're getting -2 is less than or equal to -2, which is true because it's covered from the equal. Similar to before, anything in the shaded area should be a yes. Let me go and choose another point. It can be a point right here. This is -3, 2. -3, 2. So if you put it in, you're going to have -3 is less than or equal to -2, which is true. If I choose a point, this point, it should not be working. This point is 2, 1. If I put 2, 1 in there, I should be getting 2 is less than or equal to -2, which is false. So because it's not in the shaded area, I'm getting a false statement, and no. Anything in the yellow area would be giving me a yes. Let's go ahead and do some more of these. And by the way, because for 6 and 7 I had only one variable, that is why I have those unique lines, either horizontal or vertical. Now for number 8, I don't have one variable. So my line will not be horizontal or vertical. It would be something else that I don't know yet because I have to solve it for y equals. So let me treat it as an equation first. And then I need to solve it for y to have it in y equals mx plus b. Here we go. So let me pull out the m. My m is -1. And my b is 5. Which means my starting point would be 0, 5. What else do I know? I know that this line should be dotted because of the inequality symbol. So let me go ahead and get started. I will put a dot at 0, 5, which is all the way up here. The slope, I can't use it up, so I'm going to use it down. Down 1, right 1. Down 1, right 1. And the line should be dotted, it was said, so here we go. Now, the inequality symbol says less than, and some people or students are confused with that. So I'm suggesting to you to pick a point and test it. I always pick 0, 0 unless the line is passing from 0, 0. Well, this line is far from 0, 0. So I'm going to test 0, 0. Why do I test 0, 0? Because it's an easy point to work with. So if you put 0, 0 in the original problem, here's what you have. You have 0 plus 0, which is really 0. And that's telling me that 0 has to be less than 5, which is true. So I tested this point and I got a yes, which means I need to shade everything from that half plane. Yes means solution. That's why I'm going to shade that area. So anything in here, any point in here, should be a solution. So everything down here should be shaded. So if you're confused with inequality symbol as far as what you have to shade, please always pick a point and test it. Always. Always. All right, so this is hiding all the solutions to that inequality. And if you choose something here, it should not be working. Let me go to number 9. For number 9, first of all, I don't have it. Let me put it in y equals first. So it should be x minus 2y equals 8. I need to solve it for y. Negative 2y equals negative x plus 8. Divide everything by negative 2. So if I clean that up, I have y equals 1/2 x minus 4. This is what I need to be graphing. My m is 1/2 or negative 1 over negative 2, stuff we have learned. The b is negative 4, which means my starting point should be 0, negative 4. So 1, 2, 3, 4 down. The slope is telling me up 1, right 2. Up 1, right 2, or I can go down 1, left 2 for 1 spot there. All right, my line should be dotted because I don't have equal included. So here's my dotted line. It looks like it would be nice for me to choose 0, 0 to test. Here are my two half planes, here and here. So I'm testing 0, 0. And remember, if it gives you a yes, you shade that area. If it gives you a no, you shade the other area. So this is my testing point. Let me put in the original problem. 0 minus 2 times 0, which is 0. So 0 minus 0 is 0. I want that to be greater than 8. 0 is not greater than 8. I got a no. I got a false statement. So because I got a no here, I need to shade the other area across from that. You shade the yeses. Now, according to all my work here, if I did it correctly, if I go and choose any point on the red shaded region, it should be working. For example, let's choose one point here. Maybe this one right here. This is 1, 2, 3, 4 right. 1, 2, 3, 4, 5, I believe down. So here's what I said. 4, negative 5. It should be working. Let's put it in the original. 4, negative 2 times negative 5 is positive 10. 4 plus 10 is 14, and I want that to be greater than 8. It is. True statement. So this is where all the solutions are. Finally, you can have it the opposite direction if you're having the final outcome and you're asked, for example, here to identify 3 order pairs that are solutions. Solutions are in the shaded area. So anything that you choose here and you put it down as a point, it should be a yes. So 1, 2, 3, 4. So one of my dots is 4, 2. That should be a solution. My other dot is 4, 4. And finally, I have 3, 1, 2, 3. I believe 3, 3. So because they're in the shaded area, they are solutions. And there's so many more, millions of them. But they asked me only for 3.